Welcome to Omega Virtual Learning. In today's presentation, I'll be talking to you about the volume of cuboid. And I'll explain to you how we derive the volume of cuboid and how to work out volume of cuboid. We'll also talk about how to find out meson length of a cuboid when given the volume in 2 dimensions. We'll also talk how to convert measure of volume from one unit to the other, and also understand that volume can also be attributed to the amount of liquid or capacity of a container, and also solve exam style questions. Okay, volume, let's think of it up as the amount of units cubed that fits into a solid. What do I mean by that? Look at these two shapes. I have a cuboid and a 1 cm cube. It's 1 cm because each side is 1 cm. Each side is 1 cm. If I want to find out the amount of space inside the cuboid, I can investigate it by packing this 1 cm cube into the cuboid to see how many will fit perfectly inside, and that will determine the volume of the cuboid. So let's see how we do that. So that's my first one. Let's pack as many as we can. You can count alongside. So you could see that I could fit 16 of the smaller 1 cm cube into the cuboid. So the volume of the cuboid could be written as 16 of the small 1 cm cube, or 16 centimeter cube. Now you realize that we could see this is 4 cm. Why? Because each side of the cube is 1 cm, and 4 of the cubes fit perfectly on the edge of the length, 2 fit on the width, and 2 fit on the height. Therefore, we can say the dimension of the cuboid is 4 cm, 2 cm, and 2 cm. So to work out the volume, we multiply 4 times 2 times 2. That still gives us 16 cm cube. That is why the formula is given as length times the width times the height in any order. It doesn't really matter which order. Length times width times height is the formula for cuboid. So as long as it's a cuboid, the formula is length times width times height. Cube the same, length times length because all the sides are equal. So quickly, if we're supposed to work out the volume of this cuboid, you just multiply the length times the width times the height, and that will give us 36 cm cube. Literally, it means that you can pack 36 of 1 cm cube into the cuboid box. This question is the reverse. Cuboid is given as having a volume of 120 cm cube. Height is given, length is given, width is missing. So you just go by the same formula. The volume, which is 120, is equal to 4 times 12 times a number. That is the x. So in solving equation, 48x, 4 times 12 is 48. So 48x is equal to 120. To find x, we divide both sides by 8, and we now end up with 120 divided by 48. X is 22.5 cm. To verify, 4 times 12 times 2.5 so gives you 120 cm cube. Exam question. We have a box with dimension 60 cm, 100 cm, 40 cm. And we need to fill the box with grit for winter. The box is empty. Now each bag of grit that you buy costs you £2.50. And each bag contains 8,000 cm cube. And you've been given a budget of £70 to spend. And the question is whether the person has enough money to completely fill the box. So we start by working out first how much space do we have in the box. So we work out the volume. 100 by 40 by 60 is 240 cm cube. That is the amount of space we have inside the box. Second, we need to find out how many bags do we need to fill the box. Each bag, remember, contains 8,000 cm cube. So if you want to find out how many bags, you divide the amount of space or the volume of the box by the space of the bag. So 240,000 divided by 8,000 tells us we're going to need 30 bags. We know the number of bags we need. How much is a bag? £2.50. So we need to find the total cost of the bag by multiplying the number of bags we need by the unit cost. That gives us £75. So which means to completely fill the box, we need £75. So in conclusion, we will say that the budget that we have, £70, is not enough to fill the box, because total cost of filling the box is £75, which is bigger than the actual money we have. So remember, in an exam, you need to conclude. You don't just say £75 and leave it. Without conclusion, you lose marks. Okay. Another exam question. We have a carton of milk. Dimension is 15, 5, and 8 cm. We have a milk inside the carton with the depth or the height of the milk inside the carton is 12 cm. The carton is turned such that the face green, it lands on the green face. And when that happens, we need to now find out the depth or the height of the milk inside the carton. Okay, so first is, let's try to figure out the milk is 12 cm, the height. That's how deep the milk is, 12 cm. Now you could see from the diagram that the milk forms like a small cuboid inside the original carton. So let's first imagine that this is the diagram. So let's figure out how much milk do we have inside the carton. So we find the volume. Milk volume is 480 cm cube. That is before the carton is turned. The volume of the milk is 480 cm cube. I just multiply length, weight times height. I didn't use 15 because 15 is the original height of the carton. I'm only talking about the milk. That's why I replaced that with 12. Now, we've turned the carton down, and you realize that the shape of the milk has also changed inside the cuboid because it's liquid. Let's pull it aside. Now you realize that the milk is still the same, so the volume of the milk will not change. But if you look at the dimension, this 8 is the same as the top 8, so this side should be 8. The long side, which is the height 15, is the one at the bottom here. So let's bring the numbers down. Now we want to find the depth or the height of the milk. So this question is similar to the question we did before about the reverse, finding the missing length. The same question. Volume is now 480. So we now, after the carton is turned, the milk volume is still the same. So we still have 480 as the volume, times by equals to 8 times 15 times the height or the depth of the milk. 8 times 15 will give us 120. So 480 equals 120 times the depth or the height of the milk. To do the inverse, we divide both sides by 120 to give the height. So therefore, you can say the depth of the milk is 4 cm. 4 cm. So this is an application of finding the missing length of a cuboid. It's similar to the same question we did before, but this is in a problematic form. How do we convert from one unit to the other? There are two ways that you could do this. So I'm going to show you two ways. We are given the question in millimeters, but we want the answer in centimeters. So method 1 is to carry on working in millimeters. So our answer for that will be 6,000 millimeter cube. We are now going to convert 60,000 millimeter cube into centimeter cube. We go to the original conversion. 10 millimeter make 1 centimeter. What you should do is that this is a conversion for a line. So most students don't think beyond this. This is a line. We are talking about cube. So we need to scale this conversion up by cubing both sides. So 10 millimeter cube will also be equal to 1 centimeter cube. But 1 centimeter cube will still be 1 cm cube. But 10 millimeter cube, when you cube 10, you have 1,000. So instead of using 10, our scale factor, we are now going to use 1,000. So we divide 60,000 by 1,000. That gives us 60 centimeter cube. So the answer in centimeter cube for this question is 60 centimeter cube. For method 2, all you need to do is to change each of the measurement back into centimeter before you multiply. And you know that 10 millimeter equals 1 cm. So we divide each side by 10. So that's what you're going to have. All you need to do is length times width times height, 60 centimeter cube. Let's look at another one. This time we want the answer in millimeter, a meter cube, and the question is given to us in centimeter. So first method, we work it out. Conversion is 100 cm equals 1 meter. Change it into cubes. You have 100 cm cube into 1 meter cube. And 100 cm is 1 million. So the conversion scale factor is now 1 million. 480,000 divided by 1 million is 0.48 meter cube. That's one way. Or change everything into meters by dividing each side by 100. Then you multiply. That will give you 0.48 meter cube. So one way of linking this method to this method is that you could see that the effect is in 3 folds. Divide by 100, divide by 100, divide by 100. That's why we also need to what? Cube the conversion factor. 40,000 millimeter cube into centimeter cube, the same method. We have the conversion factor. Now it's 1,000, not 10. And that gives you 40. We have conversion factor of 1 million and not 100 because we are talking about cubes. Here you got to be very careful because it's meters cube, meter cube into millimeter cube, meter into centimeter, centimeter into millimeter. That's why it's 1,000 millimeter. It's the same as 1 meter. Then you cube it. You need to understand that 100 cm is 1 meter. 10 millimeter is 1 cm. 10 times 100 is 1,000. That's why the original conversion is 1,000 to 1 meter. Then you cube it. Okay. Now you should remember that from a smaller unit to a bigger unit, we divide. And from a bigger unit to a smaller unit, you times. You should know this by now. Okay. Let's look at another exam style question. We have a box. 40 cm by 60 cm by 30 cm. And we have a van, 3 meters, 1.8 meters, 2 meters. And we are trying to pack as many boxes into the van. And the question is, how many boxes could fit into the van? I'm going to show you 2 ways. First, work out the volume of the van. 3 times 1.8 times 2 is 10.8 meter cube. Second, volume of the box. 60 times 30 times 40. 72,000 cm cube. And you realize that we are working in different units, so we need to get to the same unit. So it's up to you from what we learned previously regarding conversion of units. Either you change meters into centimeters or centimeters into meters. So it's a matter of choice which one you are comfortable with. So I'm going to make sure they have the same units. So I'm going to change the meter into centimeters. 100 cm is 1 meter. I'm talking about cubes, so I'm going to cube each conversion, and my scale factor will now be 1 million and not 100. So the volume of the van will now change from 10.8 meter cube into 10,800,000 centimeter cube. That is the volume. Now to investigate how many boxes, I'm going to divide the volume of the van by the volume of the box. And if I divide, I'm going to have 150 boxes. So that means that 150 boxes could fit inside the van. That's the first method, where you have to do the conversion like this. Let's look at the second method. The second method is where I try to first understand and convert the van into centimeter first. So I'll have it as 300 cm length, 180 width, and 200 cm. If you want to know why, I'll multiply each of the length by 100, because 100 cm make 1 meter. Next step is I try to divide. I call this the alignment method. That is when you pack the boxes, how many boxes will align with the edge of the length, the width, and the height. I do that by dividing the length of the van by the length of the box, the width of the van with the width of the box, and so on. So the alignment on the length will be 5, the width will be 6, and the height will be 5. Let's have a bit of simulation to prove that. This is the box 40 by 60 by 30. This is the van, also 200 by 300 by 180, according to the calculation that we have over here. Let's pack the boxes. That was my first layer. Now you realize that 6 of the boxes align with the edge of the length. And it's true, because 60 times 5 is 300. That is where the alignment on the L is 5. The same applies with the edge. We have 6 of them. That's why the alignment is 6. Okay. Now, to prove that the height will be 5, let's find out the first layer. How many boxes do we have? 1, 2, 3. So we have 6. 6 times 5, 30. So we have 30 the first layer. So let's keep on putting 30 in each layer. So we have 60. We had 30 before. 60. 90. 120. 150, and it fits the box. So that tells you that truly we have 150 boxes. So with this, you can see that if you put the alignment as the dimension of the box, you can find the volume of the cuboid, and you still have the same 5 times 6 times 5, and that will give you 150. So you can do this kind of work using the alignment method, dividing length of van by length of box, width of van, width of box, height of van, height of the box, and the final answer that you have for each of the alignment, you multiply them. That will give you the amount of boxes that will fit into the van. So this is the second method. So that brings us to the end of lesson 1. I hope you've enjoyed it. If you did, please subscribe, share with your friends, and hit the notification button so that you get notified as soon as I upload a video. Have a nice day. Thank you.